Now we start with discussing the difficulties coming across while writing the board paper. Board paper, they are designed to check 4 objectives. They are knowledge, understanding, application and skill. The questions in the paper, they are designed in such a way that all these 4 objectives are getting measured. To measure the first objective, that is knowledge, questions like...
Sir?
Yes?
So can you, instead of taking the doubts, can you please tell us the important points regarding each chapter?
Okay, I'll go later. First, let me introduce the things. Okay. Now, I'll tell you the types of questions coming in the board. Then we'll go chapter by chapter. Okay? Now, first objective, there is knowledge. To check that, the questions like state the law or state the definition of something is asked. Sometimes explanation is also asked. All multiple choice questions, they are memory based. So they are testing the first objective, that is knowledge. Second objective, that is understanding. How much you have understood the topic. It is tested on the basis of questions like define something or explain or small derivations. Simple sums are solved directly based on formula. These are testing your knowledge. Third objective is application. If you have the knowledge, you have understood it, then you can apply it to the new situations. That is application. It is also, the questions are coming in the form of big derivations, problems based on more than 2 steps, or combination of problems, comprehensive problem based on 2 topics. Then third type, that is skill. Skill is tested by asking the questions like draw the diagram, draw neat label diagram, that is drawing a skill. Second skill is problem solving skill. It is tested by asking problems based on shortcuts. The problem may be appearing big, but using shortcut methods, it can be solved quickly. And also, sometimes some theoretical questions are also asked based on skill. Now, in case of diagram, we can take chapter by chapter. From first chapter, 3 diagrams are asked. One is angle of banking, second conical pendulum, and third vertical circular motion. In case of angle of banking, generally problem is about the length of the cosine component of normal reaction and mg. I can draw the diagram, it will be more clear. This way. The weight will be acting vertically downward. So this angle should be 90. Normal reaction is normal to the surface, inclined surface. There also it should be 90. Then when you are resolving it, so n cos theta n sin theta. Then the frictional force F sin theta and F cos theta. Here weight is also there. Now in here the length of this part, that is n cos theta, should be equal to mg plus f sin theta. That care must be taken. The two lengths should be same. That is one precaution. Second, these angles should be 90. This normal reaction and the weight. It should also appear as 90 degree. Just writing 90 is not sufficient while drawing it, because you are checked for drawing skill. So how good you are in drawing the diagram, that is checked. For that, these precautions you have to take. In case of vertical circular motion, the diagram, the direction in which it is moving is generally anti-clockwise, and accordingly these velocities will be directed. A, B, C, here it will be this way. The direction of tension here, T1, T2, this mg is also there, here mg is up. These two directions, if arrow marks are not properly put, you will be losing the mark. And in case of conical pendulum, whatever is given in the book, that is alright. Then deriving this expression for it is involving whatever steps. Generally they are not, now they have stopped asking the theory question to derive the angle of banking or maximum velocity or optimum velocity, because that will be generally 3 or 4 marks. So 4-mark question they have stopped asking from this chapter. Then they are asking small problems or relation between V and omega, or small sum on vertical circular motion. They have asked relation between the tensions in the two positions. Once they have asked, and the topic which was very popular previously, like derive expression for linear acceleration in case of UCM, that is not asked. That is all about this chapter. Then second chapter, the different cases of projection of satellite, that diagram is asked. And while drawing the diagram, care should be taken to write the leveling given in the book. The velocity, when it is circular motion, in a circular path, then V is equal to Vc. Elliptical path, then V more than Vc but less than Ve. Then parabolic path and hyperbolic path, more than Ve, and parabolic for equal to Ve. The diagram and labeling. Then the question is coming on variation of G with depth. It is of 3 marks. and the problem is asked on the variation of G with latitude. Board, you can expect a question from board, diagram to draw the variation of G with latitude, or MCQ for G at poles, G at equator, or something based on omega of the earth, that angular speed of rotation of the earth, or how much will be the variation in G due to latitude, maximum variation in G with latitude. Recent exam, October, I think T square is equal proportional to R cube is asked, that derivation of 2 marks. Previously it was coming for 3 marks. So important steps, and diagram is not needed. If some derivation is asked for 3 marks, then diagram, description, then proof. Diagram in that case is of 1 mark or half mark, depending on the level of difficulty in that diagram. The third chapter, the very simple question is define radius of gyration and state its significance. Then about rolling body. In this board, October board, 15th October, they have asked for theorem of parallel axis, state and prove. The statement must be written as it is given in the book. Statement of your understanding will not do. Statement means your memory is tested. So how correctly you are remembering the statement or definition of something, that is tested. If you are missing some points, you will be losing marks. Then state and prove law of conservation of angular momentum. Then derive expression for moment of inertia of a ring about its tangent in its plane or in a plane perpendicular to its plane. That is of 4 marks. In October.
Sir, can you be slow?
Okay.
Frequency slow. धीरे धीरे बोले ताकि उनको लिखने का टाइम मिले.
Oh. Okay, I'll go slow. The problem, the 4 mark question.
Sir, can you please repeat?
In board exam, October board, 4 mark question has been asked for deriving moment of inertia of a ring, of a disc about a tangent A in its plane and B in a plane perpendicular to the plane of the disc. Similar question can be expected for a ring. Moment of inertia of a ring about an axis, about its tangent in its plane, and second tangent perpendicular to it, its plane. So
So what did you say for 3-mark questions like diagram then?
Diagram, then
Diagram.
description, diagram, description, then proof. Sometimes this diagram and description together is half mark. Diagram may be very simple, so it is of half mark. In that case, labeling is not checked. Only a diagram and description 1 or 2 lines. Description, if proper diagram is drawn, then description may not be required. Only labeling or the values involved or the symbols involved should be explained. That's all. In third chapter, now the problems based on theorem of parallel axis or perpendicular axis can also be asked for 3 marks, or simple problem then 2 marks. From chapter 3, no diagram is expected as a separate question. It will be part of it. Like if they are asking derive expression for torque of a rotating body, in that case diagram will be needed. And not very artistic diagram, but diagram and description that will cover one mark at the most. Then fourth chapter, it is oscillations. The question which board has asked in October is composition of 2 SHMs, analytical method. That question is coming once in a 3 year. Now you can expect a question, another question from that chapter, like derive expression for simple pendulum, period of simple pendulum. There is 4 mark question, or a sum based on it. When length is increased, period increases that much, then that type of thing. How much is original length? Or a diagram from this chapter coupled with a table is asked for drawing the diagram for displacement, velocity and acceleration of a body performing linear SHM starting from mean position or extreme position. In that case, writing expression for x, v and acceleration will be of 1 mark. Preparing table for different values of omega t or pi or t will be 1 mark, and drawing diagram 1 mark. You know, if it is starting with mean position, then a sin theta, a omega sin omega t. If it is starting with extreme position, whether plus or minus immaterial, that will be cos. X is equal to a cos omega t.
Sir, can you repeat the last question?
Yes?
Sir, can you repeat the last? Sir, can you repeat the last?
Yes. When you are asked to represent graphically the displacement, velocity and acceleration of a body performing linear SHM starting from extreme position, in that case the expression will be x is equal to a cos omega t. Differentiate it once, that will be velocity. Differentiate that velocity, it will be acceleration. In small thing, they may ask you to draw for a body starting from extreme position, so plus x or minus x. That can they mention, but don't worry. It will be cos only, no minus plus sign. Then diagram for a body performing damped oscillation and write expression for its period. That can be for 2 marks. Or damped oscillator diagram, then what happens as a result of damping? Period increases, amplitude decreases. That can be asked as a multiple choice question from the same topic. Then problems are asked from this book, which are standard problems given in the book. As an odd problem, you can expect a solved problem from the book based on force constant. Based on force constant, which is already solved in our board's book. This type of sum. Then the particle is executing SHM of amplitude A. What fraction of total energy is kinetic? When it is displaced, its displacement is half the amplitude. At what displacement is the kinetic energy 3 times that of potential energy? It is a solved sum. This type of sum you can try. Or solved 11th, when length of simple pendulum is increased by some length, period changes by this much, find original length. Then what I was telling, this last solved sum, that is 17th, a body of mass 1 kg is made to oscillate on a spring of force constant. Calculate angular frequency, frequency of vibration and period of vibration. This type of sum has not been asked in the board, but as an odd question, if it comes for 2 marks, or in MCQ for one thing, either for angular frequency or period, then you should be ready for it. Then odd question from this chapter is show that SHM as projection of UCM on any diameter. That question is coming once in 2 or 3 years. That is an odd question. Then from elasticity, definition of shearing strain, shearing stress, Poisson ratio, then MCQ on compressibility, then variation of Poisson ratio for given body like homogeneous isotropic material, then in actual practice sigma is positive, always positive, and its value is given. Then the very popular question, behavior of wire under increasing load, with diagram, that is stress strain graph showing different things like elastic limit, permanent set, yield point, breaking stress and breaking point. As a shock, so far they have not, board has not asked, but you may remember this also, figure 5.7, stress strain curve for the elastic tissue of aorta.
Sir, can you repeat it from the start of chapter 5?
Chapter 5, okay,
Can you repeat from the start?
yes, yes.
Which one was the
Definition of shearing stress, shearing strain, Poisson ratio, then variation of Poisson ratio for homogeneous isotropic material given in the book page 82, and in actual practice sigma is always positive and its value is also given. Then repeatedly a question has been asked, that behavior of metal wire under increasing load. 5.8, topic number 5.8. The diagram can be asked, label diagram for 2 marks, or the full topic for 4 marks. Then as an odd question, the figure 5.7, stress strain curve for elastic tissue of aorta, the large tube carrying blood from the heart. The diagram is given. So this specific diagram can come as MCQ or as a diagram to draw. Then MCQ on sage or buckling of a beam. Then derivation of elastic energy, that prove that strain energy per unit volume is half stress into strain into this. This is in the book, last topic of the chapter. There, while writing answer to this, the definition of strain energy must be given. If you do not write it, half mark will be cut. And it should be written as it is. Strain energy is defined as elastic potential energy gained by a wire during elongation by stretching force. Then sum based on compressibility, bulk modulus, or simple sum to find modulus of rigidity or shearing strain or stress. Also, the problem involving frame of brass plate of an outdoor design has area, thickness, it experiences shear force due to earthquake. How large a parallel force must be exerted on each of the edge if the lateral displacement is this much. This type of sum. Then chapter 6. In October exam they have asked for relation between surface energy and surface tension for 2 marks. It has been repeatedly asked. This question is very popular. Then definition of angle of contact and its characteristics. While writing this definition, the last line, angle of contact, when liquid is in contact with the solid, angle between tangent drawn to the free surface and surface of the solid at the point of contact measured inside the liquid. Measured inside the liquid. That should be mentioned. If you miss that, you will be losing the marks. Then explanation of angle of contact. The diagram showing adhesive and cohesive forces. Then derivation of pressure difference inside a liquid drop or bubble. In fact, in last exam they have asked problem based on a drop. Then diagram of rise of liquid in capillary tube. Rise of liquid in capillary tube showing different forces. Here this topic can be asked for derivation also. Derivation for rise or to determine surface tension. Then 1 mark problem based on variation of temperature and surface tension. The formula T is equal to T0 bracket 1 minus alpha theta. Based on that, 1 mark MCQ or numerical MCQ.
Sir, can you repeat?
Yes, yes. T is equal to T0 bracket 1 minus alpha into theta. Here temperatures are in absolute degree. Capital T it is. So temperatures are in absolute scale. T is for surface tension, theta is in degree Celsius, not in absolute. Sorry. Then, in the summary, points are given. You can see point number 10, work done is merged to form a single drop of radius r from n droplets of equal size is equal to 4 pi r square capital T bracket n raised to 1 by 3 minus 1. And the 12th one, work done in breaking a drop of radius r into n droplets of equal size is 4 pi r square T bracket n raised to 1 by 3 minus 1. this formula directly given, and in fact they have asked once this as multiple choice question. Then one multiple choice you can expect that 13 point surface tension of water at 50 degrees Celsius is 67.8 into 10 raised to minus 3 Newton per meter. Because generally you remember it as 75.5 into 10 raised to minus 3 at 0 degree Celsius. So at 50 degree this is temperature and this number is already given, so this can be asked. Generally numbers are not asked, but here it can. Then next chapter, or from this chapter, H1R1 is equal to H2R2, numerical, small numerical of 2 marks or 1 mark.
Sir, can you please go slow and start from the first one?
Okay, this problem based on capillary rise involving the formula H1R1 is equal to H2R2. Radii of two capillary tubes are given. Height of liquid column in one is
Sir, please, H1R1.
Pardon? Yes, please.
H1 equals H2R2. So where is that H1R1 equals H2R2?
This is page number 104. 104
Thank
of our textbook. Textbook, page number 104. Then a problem like calculate the force required to take away a flat circular plate of radius 0.01 meter. That is unsolved question, problem number 1. Unsolved problem number 1. Flat circular coil, it can be rectangular coil or shape will be given. Then we can go to 7th chapter. The first topic, 7.1, the derivation of simple harmonic progressive wave. Simple harmonic progressive wave traveling in positive x direction. That is one. It can be traveling in negative x direction. Then change of phase as a result of reflection. Change of phase as a result of reflection of transverse wave from rigid boundary or from rare medium. Then diagram of Quincke's tube experiment. diagram of Quincke's tube experiment. Then analytical method to find frequency of beat. Analytical method to find frequency of beats. Then explanation of Doppler effect in sound. Explanation of Doppler effect in sound. And explanation of two applications of Doppler effect. Explanation of two applications of Doppler effect. Then problem based on
Sir.
yes.
Sir, applications are more important and limitations are more important.
Applications of Doppler effect in sound. Two applications are to be explained as given in the book. You can choose any two applications from the book. And
Sir,
yes,
sir, I'm asking, the application of Doppler effect more important or the limitations of Doppler effect?
application of Doppler effect. Then problem based on simple harmonic progressive wave equation. Simple harmonic progressive wave equation is given and you are asked to find things like wavelength, frequency, velocity. And another problem based on beats. That set of 31 tuning forks like this problem in series in decreasing order. Yes? Okay. A set of 31 tuning forks is arranged in a series decreasing frequency such that each fork gives 5 beats per second. That's solved sum in your textbook. Fifth, this type of sum.
Sir, can you please repeat? Actually, Borivali Center got disconnected from chapter 7 से जो भी बताया आप repeat कर सकते हो please?
7 chapter 6. Acha, I'll repeat. Okay, one sec. Equation of simple harmonic progressive wave. Its derivation. Okay, traveling in positive x direction or negative x direction. Second, reflection of transverse wave from rigid boundary or rarer boundary. Then problem based on simple harmonic progressive wave. Problem based on simple harmonic progressive wave equation is given. You are required to calculate wavelength, velocity, frequency, etc. Anything can be asked as per the given data. Then diagram of Quincke's tube experiment. Then two applications of Doppler effect. 2 applications of Doppler effect. Then problem based on beats, theory of beats, as given here. Solve problem 5, page 117. Set of 31 tuning forks arranged in series of decreasing frequencies. That type of sum, number may change. Then 8th chapter, analytical method of deriving the equation for stationary wave. That is 8.2 topic number 8.2. Giving conditions for nodes and antinodes.
Sir, can you repeat from chapter 8?
Chapter 8. Formation of stationary wave on string using analytical method. And giving condition for nodes and antinodes. And show that distance between two successive nodes is lambda by 2. Then distinguish between harmonics and overtones. Distinguish between harmonics and overtones. Prove that only odd harmonics are present in case of air column in a pipe closed at one end. Then a formula on the page 124 for specific gravity sums n1 upon n2 is equal to under root sigma upon under root sigma minus 1. Then for end corrections, small derivation.
Sir, is the box on page 123 also important?
123, that stress is equal to strain into Young's modulus given in the box.
Yes, sir.
Yes, it is a
Yes,
comprehensive
sir, that
topic. You prepared this also. Useful for all problems. Then end correction. Then distinguish between resonance and forced vibration. Then problem on Milde's experiment.
Sir, can you repeat?
Milde's experiment. That formula is given. Equations are given for parallel and perpendicular position. Melday's experiment. Page 129. Then chapter 9, kinetic theory of gases and radiation. This chapter, now board has started asking questions like, show that RMS speed is proportional to root T using kinetic theory of gases, or derive Boyle's law using kinetic theory of gases. Also, problem based on the formulae given for kinetic energy per unit volume, kinetic energy per mole, kinetic energy per molecule. Pardon? Yes?
Can you go a bit slower?
Okay. The problem based on the formula. See, things are given on page 143 of my book. This kinetic energy per unit volume. Kinetic energy per mole or kilomole. Kinetic energy per molecule. And kinetic energy per unit mass. These four formulae are there. Based on these.
Sir, can you repeat from chapter 9?
Chapter 9. Yes, I am doing that only.
So please, you don't need to repeat each chapter again and again, as they are saying.
Okay. Now, go for multiple choice question. Can be from degree of freedom and application of specific heat capacities.
So,
Yes.
so it's better to go slow than repeating the whole chapter again.
Okay. I'll try. Multiple choice question.
Sir, we are comfortable with your speed.
Okay. Thank you. Degree of freedom from that topic. Multiple choice question. Then specific heat capacity for monoatomic gas, diatomic gas, polyatomic gas, specific heat capacity of solids, and specific heat capacity of water. From these topics you can expect multiple choice question, like specific heat of water is 9 R, that for solids is 3 R, this type of MCQs. Then distinguish between heat engine and refrigerator. Then neat level diagram of perfectly black body. Then next is spectrum of black body radiation in terms of wavelength. The diagram and explanation. Followed by Wien's displacement law. Then units and dimensions of emissive power. Then Kirchhoff's law and its theoretical proof.
Sir, instead of telling what
Stephen's law, problem based on Stephen's law and Newton's law.
So just carry on.
Then MCQ based on greenhouse effect. Then wave theory of light, diagram of reflection at plane surface. Diagram of reflection at plane surface. Then diagram as well as proof of law of refraction. Law of refraction using plane wavefront. State and explain Brewster's law. Then uses of Polaroids. And note on red and blue shift. In board, repeatedly a problem based on width of plane wave front is coming. The solved one, the solved problem 4 was page number 169. Parallel beam of monochromatic light. That fourth problem, which is solved, and unsolved is also based on that is all from this chapter. Next is interference and diffraction.
So what from unsolved? So what did you say from unsolved?
Unsolved problem based on width of a wavefront.
Thank you.
See, fourth one is solved. Solved fourth one.
दादर सेंटर माइक ऑफ करो अपना दादर सेंटर माइक ऑफ करो
Then interference and diffraction. Conditions for constructive and destructive interference. In terms of path difference and phase difference. Then conditions for producing steady interference pattern. State and explain. Then importance of Young's experiment. Importance of Young's experiment. Then measurement of small d, measurement of small d in biprism experiment. The diagram explanation. Ray diagram, arrow marks are compulsory. Then distinguish between interference and diffraction. Then problem based on resolving power of a microscope for self-luminous and illuminated objects. Then Rayleigh criteria. Then problems based on biprism experiment. And diffraction pattern. Like a single slit diffraction pattern problem is given. Yes. Then electrostatics.
Sir, can you please give the question numbers?
Okay. Application of Gauss's theorem. For uniformly charged infinite plane sheet. Application of Gauss's theorem to charged infinite plane sheet. Then mechanical force per unit area of a charged conductor. Then energy density of a medium. Then polarization of dielectric. That topic given on page number 197. Textbook 197. Polarization of dielectric slab subjected to an external electric field. Then effect of dielectric on capacity. Then one Van de Graaff generator, its diagram can be asked. Uses, diagram or uses. Then problems from unsolved. The last sum, page 212, textbook, page 212, last problem. And another problem based on charging of a capacitor. Charging of a capacitor. Based on that, Then chapter 13, current electricity. State and explain Kirchhoff's laws. State and explain Kirchhoff's laws. Then Wheatstone Bridge balancing condition. Problem based on meter bridge. Then principle of potentiometer. Principle of potentiometer and numerical to find internal resistance. Internal resistance. Then 14th, magnetic effect of electric current. Ampere's law and its applications. First topic, statement and one of the applications. Out of 3, one application can come. Then construction working of moving coil galvanometer. Then discuss the sensitivity.
Sir, can you repeat what you said for moving coil galvanometer?
Construction and working. Construction and working of moving coil galvanometer.
Thank you.
Then discuss the sensitivity and accuracy of moving coil galvanometer. Small sum based on voltmeter. Then diagram of cyclotron showing D's only, that B diagram, B principle of working of cyclotron, that diagram, not the actual one. Then time required to traverse semicircle, that can be asked as MCQ. In fact, it had come once. Then expression for period and frequency in cyclotron. Then limitations of cyclotron. 4 limitations are given. Then magnetism. The topic 15.2, magnetic dipole moment of a revolving electron. And the next topic 15.3, magnetization and magnetic intensity. Everything from these 2 topics. The last topic of this chapter, domain theory on the base for ferromagnetism. Ferromagnetism on the basis of domain theory. and what happens above Curie temperature. And problem based on susceptibility. Then
Sir, can you please give the question number?
question number theory question number. See, topic number I gave you, the 15.2 and 3, and the last topic, that is ferromagnetism on the basis of domain theory. Then problem for practice. From there, problem based on susceptibility is there, 5th is there, 6th is there. Even 7th is also involving that. Then electromagnetic induction, laws of electromagnetic induction, means all 3 laws. All 3 laws of electromagnetic induction. Then theoretical proof of E is equal to minus d phi by dt. Theoretical proof of E is equal to minus d phi by dt. Then 2 applications of AD currents. Explain 2 applications of AD currents. Then transformer, topic 16.5. The full thing. It can be diagram, it can be construction and working, or MCQ for step up and step down transformer, transformer ratio. Then capacitance and impedance. Then in recent board exam, they have asked for power in AC circuit with resistor. Topic number 16.10. Page 270. Power in AC circuit with resistor. You can take second also. Power in AC circuit with inductor, capacitor and resistor in series. Then rejector circuit and acceptor circuit. Definition of power factor and value of power factor for inductive and capacitive circuits.
Sir, can you repeat the last one? The last
Rejector
one.
circuit, inductor circuit, then definition of power factor, then value of power factor for inductive and capacitive circuits. That can be MCQ. Then chapter 17, the topic 17.12, the diagram of experimental setup. Then threshold frequency, threshold wavelength, stopping potential, then diagram of photoelectric cell, and explain its applications, two applications. Explain its two applications. Then MCQ can be from topic 17.4, particle nature of light, the photon. And the problem, almost all the problems are involving same thing, so they are of the same type, so all unsolved problems. Then atoms, molecules and nuclei. State Bohr's postulates. Bohr's postulates. Derive expression for radius, velocity, energy, then energy level diagram for H atom, energy level diagram for hydrogen atom, then definition of mass defect, binding energy per nucleon, and the graph of binding energy per nucleon against mass number, that diagram 18.4, page 299. Binding energy per nucleon against mass number, that graph. Then radioactive decay, decay constant, half-life, then distinguish between nuclear fission and nuclear fusion. Then how concept of matter wave.
Sir, excuse me, sir, can you please repeat it? So the last part.
Distinguish between nuclear fusion and nuclear fission.
Okay.
Then explain how matter wave solve the puzzle of Bohr's second postulate. Then diagram of Davison-Germer experiment,
मालूम कितने नंबर ऑफ डाइपोल आ रहे हैं
that is figure number 18.7. The experimental setup of diffraction of electron, the Davison and Germer experiment, this diagram and its importance. Then semiconductors, energy band diagrams for conductors and semiconductors.
आज का ये होगा
Then PN junction diode, biasing and barrier potential, biasing of PN junction. Then what is barrier potential? What is depletion layer? Then rectifiers, full wave and half wave rectifier. Then about Zener diode, photodiode, solar cell and LED. Either advantages or uses or applications. Then relation between alpha and beta for a transistor.
Sir, can you repeat from Zener diode, please?
Zener diode, LED, solar cell, photodiode. About these diodes, either it is asked advantage of one or application or uses. So, the relation between alpha and beta for a transistor. Then explain transistor as a switch. Then what are oscillators and state the condition for sustained oscillations. Then gates, about gates, one MCQ or diagram. Then communication system. Two definitions which are given here. Some 12 definitions are given. Out of these, two, any two can be asked. The need for modulation, any one of the three. Need for modulation, three needs are given. Out of three, any one, and that will be specified. Then space communication, the Earth's atmosphere, different layers are there. Multiple choice question can be asked from their composition, height or temperature. Then MCQ from ground wave propagation, sky wave propagation, space wave propagation. And the last statement of the chapter, that fading, disappearance of signal for short time due to variations in height and density of ionization of ionosphere is called fading. That is all. Thanks.
Sir, can we learn the definition from Navneet Digest?
See, you compare that definition from your given in the book. If it is matching, all right.
Sir, they are a bit different, so will it do?
No, man. See, certain points which must be mentioned, they are given in the book. If those points are missing and you write so many things, then also it will not help. See, definitions are to check your memory. If you are memorizing anything properly, then only you will be given credit. Okay?
Sir,
Yes.
sir, for the values of constants like Planck's constant h and pi, sir, till
They are
what
given.
decimal places should be taken?
They are given. They are given in the book, question paper.
Okay, thank you, sir.
So can you please tell something about time management?
Pardon?
Can you please tell us about time management?
Time management. Okay. See, if you are good in problem solving, you start with numericals. So you can save time. Or for derivations, diagram description, you cut short. Because description is not carrying much marks. Whether you are writing it for 10 lines or 3 lines, marks are half only. So that way you can manage. Okay?